Okay, so welcome to today's lesson. What we're going to do first of all is we're going to review slopes. So here we have a worksheet, what you call a duck that steals. We have gained slopes from the graph, which we can do quite easily. Remember, you make a triangle between 2 points to find your run, which in this case is 3. So m equals rise over run. And so we know the bottom value is 3 because we counted 1, 2, 3. So the run equals 3. And then our rise, we simply go up 1, 2, 3, 4. And so your rise equals 4. So your slope is 4/3. So then you can go and solve the puzzle. To solve the puzzle, you find your answer 4/3 and you cross it off. So there's 4/3. I cross it off. And is there another 4/3? No. Whatever's left over will make your phrase. Now, what about when you have 2 points? So question number 7. So if you have 2 points, what you need to do is you need to plot them. Where you do, it's up to you. You can do it on any grid you want. What I would do is just choose one of these grids that work. So for number 7, I'll do it up here. 2, 1, up 2, up 1 is going to be right here. And then 5, 3, 1, 2, 3, 4, 5, 1, 2, 3 is right here. And so now I have my line so I can count. So my rise will be 2 and my run will be 1, 2, 3, 3. So my slope will be rise over run 2/3. And so that's the answer for question 7. Okay, but what you need to do is just you need to plot on a grid. Okay, now sometimes they might not work. So for example, for question number 7, I wouldn't use this grid because the points aren't there. So don't use that grid. Use a grid that works for the points. Okay, if none works, you might have to use another sheet of graphing paper and make your own grid so you can count. Any questions? Let me know. Next thing we're going to work on then is graphing special lines. So what we're going to just review table of values. Again, if you have an integer, right? So this here is an integer. What numbers should you be using? Well, if it's an integer, you're always, for your x value, you're always going to use -2, -1, 0, 1, and 2. Always. Substitute in. Now you gotta be careful. I had some people that didn't substitute with brackets and then they screwed things up. They forgot their signs, they didn't double signs up, or they just did a little bit of math there because the signs weren't separated. All right, so do your little bit of math. Y equals -2 times -1 plus 4. Y equals +2 plus 4, so y equals 6. And the next one is 0, so y equals 0 plus 4 because of the multiplication. Remember, -2 times 0 plus 4, that's why we get the 0. And you should be able to see that, you're starting to see that pattern, you should be able to see it. So now I can see my rate of change is going up by 1, and here I'm going down by 2. So my rate of change is -2. And you can use that to continue the pattern. You'll notice that right here, there is your rate of change sitting right there, or your slope. So your rate of change equals your slope. They are the same thing, just different words. We usually use rate of change when we're looking at more applications, so real world graphs, and we use the word slope kind of interchangeably. So this here would be 2 and this here would be 0. So quickly we can plot those points. -2, 8, -2, and then 8 is up right here, just barely on our grid. If it wasn't on our grid, we just wouldn't plot it. We'd go to the next one. But it was on our grid, 0, 4. You can see now I'm starting to have a pattern, and 2, 0. So use your ruler, and if you don't have a ruler, just take a sheet of paper and fold it twice. You'll always get a straight line with that. Good, and let me just fix that a tiny bit. And once more. So what do we have to know about our lines? Well, we have to have, number 1, they got to be long, okay? Long lines. Number 2, our lines must touch the edge of the grid. Oops, edge of the grid. Oops, sorry. Edge of grid, or what else? Or arrows. Okay, without arrows or touching the edge of the grid, then you're going to be going and not having a line that goes forever. Okay, so this means it goes forever. So you're not just connecting the dots. You're making a line. You're based on the points that are plotted. So that means it goes forever as well. Crossing the grid here also means it goes forever. Okay, so you got to indicate that. Now, next equation, we did this with our cryptic quiz. We don't know which ones to plot yet. Why? Because it's not until y equals, so we don't know if our slope is an integer or a fraction. So let's move 8x over, minus 8x both sides, and we're left with negative 6y equals negative 8x plus 24. You always want your x value inside and your constant on the outside, so you're in the y equals mx plus b format. Then you're going to divide by negative 6. So what happens? It's both parts being divided by negative 6. Okay, so I've kind of shown exactly what's happening there. And then I have to simplify my fractions and my signs. So both negative signs will be gone. I'll have a positive final value. Divide 8 by 2, I get 4. Divide 6 by 2, I get 3x. And then this divides to negative 4. So now I know what to use for my table of values. Okay, so with my fraction, for my fraction, I have multiples of 3 because that's the denominator. Multiples of 3. So I will go negative 6, negative 3, 0, 3, and 6. Those numbers will cancel out my fraction, so I have whole values to plot. Okay, so then let me do a little bit of math. So y equals positive 4/3 times 6, using brackets to multiply, minus 4. So y equals, those cancel to 2. 8 minus 4, y equals 4. Okay. Next one, let's see. Y equals 4/3 times negative 3 minus 4. Oh, Mr. Barker, big mistake. That's supposed to be negative 6. So that should be negative 8. So that should be negative 12. Okay. Now that's not even going to be on our grid. Like that's going to be way down here. So I won't plot that point. So I better get some more that are on my grid. I hope this works out. Negative 1, so that is negative 4 minus 4, so y equals negative 8. All right. And then 0, well, what happens with 0? I will just get negative 4 because the x term cancels out. Now looking at this then, I can complete the pattern. So this would be 0, and then this would be positive 4. So I can plot those now. Okay, I can't plot the first point, but negative 3, negative 8 I can plot. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Right on the edge of my grid. Good. Next one will be 0, negative 4. That's easy. And then we have 3, 0 right here. And then we have 6, 4. Here's 6, 1, 2, 3, 4. There we go. Now you got to make a nice, beautiful line. Now that I have two lines on there, I can't tell which is which, can I? So how can I communicate that which question belongs to which line? You're right. I can label them. This I would label line A because it's for question A. And this I would label line B because it's for question B. Man, I feel like I'm doing the test right now. This is exactly what your test looks like. You have these three question types and a graph, and you got to graph it. Honestly, certainly pays. Listen to the video. Okay, so for the axes intercepts method, what I do is I set x equal to 0 to find an intercept. That's when I'm going to be crossing my y-axis. So I get 4 times 0 minus 6y equals negative 12. And I get 0 minus 6y, which is negative 6y. Often we forget this negative sign in front of the 6. You've got to remember it's there. Watch for it. I'm going to give you a question like that. So this point value is 0, comma, positive 2. And then I substitute in y equals 0 to find my other intercept. So I get 4 times x minus 6 times 0 equals negative 12. So that becomes 4x equals negative 12 and x equals negative 3. So this would be a negative 3, comma, 0 value. Okay, so now I go and I plot them. So I get 0, positive 2, and I get negative 3, 0, and now I can make this line C. So I'll go and get my ruler and cross the edge of the grid. Notice how Mr. Barker always uses arrowheads and he crosses. It's like he never wants to get it wrong, and yet sometimes you guys don't do either. Like you want to get it wrong. Okay, and this is C right there. So there we go. Those 3 questions, 100% guaranteed, going to be on your test. And they say math is hard. All right. So these ones all have a slope. But what we're going to do is we're going to have some special lines where our equation is different. Okay. So special lines. This y equals 4. So what we do for y equals 4 is you want to plot the point y equals 4. Okay, so if you have y equals 4, it's right here. And then what you have to understand is that every point is y equals 4. So what we know is that the line goes through y equals 4. So if it goes through y equals 4, it doesn't make sense to go here because then it would go through every y value. It doesn't. It goes through one y value. So this equation always has y equals 4, and basically what you have then is a line that goes right here, right along y equals 4. So the value never changes. Okay, every point has y equal 4. So you're going to get your ruler, and this is a special line, and you're going to draw it. Now what you want to do is on your graph, make it thick. Okay, so here's our line, y equals 4. Note, make the line thick, so you can see it. All right, now I have colors and arrowheads, so I'm kind of lucky that way, but that's what you need to do if you're graphing on your own. Okay, and so the next equation, x equals 3, with that equation, what it means that every point has an x equal 3 value. So I find x equals 3, it's right here. And in order to make a line that x equals 3, it's going to be all these points that go up and down. It can't be along the axis. It never will be. So don't make your point there, because if it's along the axis, every x value will be different, but it's not. Every x value is the same. So describe the graph of the above equation. It is a horizontal vertical line with x equals 3 for every point. Whereas the one previously, it wasn't a horizontal line, a vertical line, it was a horizontal line. Okay. And these lines have special slopes. Okay, so x equals 3, we have a vertical line that goes straight up and down, and so now I'm just going to draw my line. Every single point has an x value of positive 3. So really, basically, we are crossing the x-axis at 3. Okay, so it crosses at x equals 3. This one crosses at horizontal line crosses at y equals 4. Y equals 4. Okay. Good, so let's practice a couple different situations. Here we have y equals -5. So y equals -5 is down here. And so it crosses at y equals -5. So that is going to be a horizontal line. Keyword, need to know horizontal. So I would make my line with my ruler just like that. No, I would use a ruler because I want to demonstrate proper stuff to do. Good. There you go. Here, x equals 5, so it crosses at x equals 5. Crosses at x equals 5. So here's x equals 5, so it's going to cross the axes right here. And x equals 5 is down here. Just about had you, haha. And here we go, nice beautiful line. So if it crosses it, it's going to be vertical, not horizontal. And so you can say this one is vertical. Okay. Now you're going to get some questions like this. Okay, so the questions like this here, you would say divide by 2 both sides. So you get x equals 3. And so here's your 3 value, so it crosses right there. And you have, what kind of line is this? It's vertical. So our options are vertical, horizontal, or oblique. Every other line that we've been graphed so far is oblique, which basically means it's not vertical, it's not horizontal. So divide by -3, and so you get y equals positive 6. So here we go, there's positive 6, it crosses right there, and boom. Okay. So what if we had something like y equals x plus 2? So we have x plus 2, we would have to do our table of values, and we know our table of values would be -2, -1, 0, 1, and 2, because we have an integer. And so this would be 0, this would be 1, this would be 2, this would be 3, this would be 4. So I'd go and plot those points. There's -2, 0, -1, 1, 0, 2, 1, 3. And so I would then make my line right here. I'd label it y equals x plus 2. And so this is what we call an oblique line. Okay, so basically it's not vertical and it's not horizontal. All right, so any of those two, if it's vertical or horizontal, there you go. Now what about going backwards? So line A, it crosses, it's a special line, and it crosses at y equals 6. So the equation is what? You guessed it, y equals 6. Okay. Line B. So line B is right here. What does it cross? It's special. It crosses at 3, 0. And so it would be, it crosses at x equals 3. So the equation is x equals 3. So special lines have special equations. Line C, right here, that's going to be x equals -6 because that's when it crosses the axis. And line D, it crosses out y equals -8. And so that's going to be the equation. Okay, so these are special lines with special equations. So let's go look at your homework for today. First part about your homework, I'd really like you to complete this worksheet that was at the front here. What do you call a duck that steals? Okay. You have some textbook work to do, as well as this worksheet is your regular thing. Okay. Now, number 1 and 2 are easy. For question number 3, you have to turn it into y equals mx plus b. And then, looking at your m, you have to use the correct table of values. Okay, so same thing with all these other equations as well. You have to turn into y equals mx plus b. So it's like cryptic quiz, and then use a table of value. And you got to use the right one, whether you have an integer or a fraction. Okay, you won't be able to plot all your points, but you'll have enough, at least 3 on your grid, to make a straight line. Good. And then we go to some special lines, and then number 9 again is going backwards. So you have some special lines intertwined with regular lines. This is kind of like a full meal deal practice for your test. You got to figure out which graphing method to use. If you could use axis intercept if you want, but I'd rather you not, because these questions aren't going to be cooked up. Some of them will be fractions for your intercepts. Hard to do. Down below, you'll cross off the letters, and then you have your answer. All right, good luck, enjoy, have fun. Almost done. Let's go.